So just taking up a couple of more from the review worksheet that we didn't quite get to when we did the review lesson together. And I just want to stress a few points so that you're ready for the test. So I'm actually going to do one that we did do in class, but I'm going to do it again to stress how important it is. So this is trying to solve 2 to the x equals 9. We realized right away that we can't do a common base, so we have to go to our strategy, and the whole reason why we learned this is to take the log of both sides. We see that we have log 2 to the x, so that exponent x can come out front. Now we can isolate for x by dividing by log 2. And this one did ask for a decimal answer, so we go to our calculator and punch that in, and we get 3.1699 when we go to 4 decimal places. Okay, that's a really, really big step. So it's important that we know how to do that. Now I'm going to compare it to one that we didn't do in class, and that's number 9. Okay, so number 9, it says solve these in 3 different ways. Well, for starters, I'm actually going to change it and say only 2 different ways. So the 2 different ways, the third way is to do this graphically. And it used to be that I would show you how this worked on the graphing calculator, and to solve it, you would graph 125 to the x and 25 to the x minus 1 and get 2 graphs. And then wherever they intersected would be a solution. We're not going to get to the graphing calculator, so we're just going to do it 2 ways. Hopefully, the one way that we all see right away, and the easiest way, is to recognize that we can express 125 and 25 into a common base. So one method is common base. So the common base in this case would be 5. So 125 is 5 to the power of 3. And it's being raised to the power of x. And then 25 is 5 squared, and it's being raised to the power of x minus 1. Of course, now we have 1 base and 2 exponents, so we got to multiply these exponents. Well, that's easy over here. It's just 3x. But when we multiply this by this, we got a little mini rainbow. And we have 5 to the 2x minus 2. The whole reason we like common base is so that now, once we have the common base, we can ignore the bases and just look at the exponents and say the only way this can be equal is if we say the exponents are equal. In this case, 3x being equal to 2x minus 2. A quick algebraic step gets x equals -2 by subtracting 2x from both sides. And there's our answer. So this is an efficient way to solve these answers. Another method is if you didn't notice that you could do a common base. And we would use logs, just like we did in the previous question. We're going to take the log of both sides, because that's a strategy. So the good news is it's going to work, because we can take the log of both sides. It's just a little bit easier if we notice there's a common base. But we're going to use logs and pretend we didn't notice. So we'll take the log of both sides. And of course, we do this so that we can bring the exponents down. In this case, the exponent is x, so that x comes out front. And this exponent is x minus 1, log 25. Now we need to somehow get all the x's on one side. Well, the problem, of course, is being rainbowed, or sorry, on the right-hand side is it's got this x minus 1 and this log 25. So this is the case where we rainbow. And the reason is we're rainbowing a number. If you recall last week when we did a question, and I think Casey asked about, can I rainbow the log? You couldn't last time because it wasn't a number. This is a number. This is log 25 base 10, so it's an actual number. That number you can rainbow. So this is another reason why I wanted to do this today. So if I rainbow this, it becomes obviously x log 25. And then it's a positive times a negative, so it'd be negative, and 1 times anything is just itself, so negative log 25. And over here we just have x log 125. So that made thing a little bit easier because now at least I have x in some sort of term. Whereas before, so there it is in the term, before it was stuck in here. So because it's in a term now, we can bring it over here. So I'm going to subtract it. So x log 125 minus x log 25. And I'm going to leave this negative log 25 on this side because it's just a plain old number. Now on the left-hand side, we'll be tempted to collect like terms. So you want to bring those x's together. One way to do it, and if you recall we did this, is we take out a common factor of x. So if we take out that common factor of x, we're left with log 125 minus log 25 equals negative log 25. And the good news is that the x is now very close to being by itself. And I can take this whole thing and divide it over here. And I will get x equals negative log 25 on the top all over log 125 minus log 25. And at this point you can go to your calculator if you want. Some of you may see that thing that I moved that's on the bottom, this here, since it's the same log, can be expressed as a single log, and you might want to do that. So this top's just staying the same. But the bottom, because it's minus, you can combine these into a single log by dividing. So it would be log 125 divided by 25. So that might make things a little bit easier. Again, you could have used your calculator here, and that would totally be fine, but you can see how things are getting a little bit nicer here. Log 25 over log, well, how many times does 25 go into 125? What happens 5 times? So now your math's a little bit easier. You use your calculator here, and you're going to get negative 2. Which, luckily, is the same as up here. The last thing I might be curious on is your opinions on which is better. Well, of course, for this particular question, there's no question at all. The first method is better, finding a common base. The math is easier, it's shorter, everything's straightforward. And the using log methods, if you forget to do a common base, look at how much work you need to do. Of course, when you can't find a common base, like in this, you have to use the logs. But in this case, you could. So if you're commenting on which is better, we're going to say, of course, the common base is better. When you can. What's the pro of using the log ones? Well, the good news is the log one works all the time. So if I had to compare these, I might say, well, the advantage of the common base is if you can do the common base, it's much quicker and easier. Less chance for making an error. But if you can't, you have to use logs. So the advantage of logs, even though it takes a lot of time, the advantage of logs is it's going to work all the time. It works when you can take a common base, and it works when you can't.